OpenCV started when I was working as a quant on an option trading floor, and I was getting sick of that life. So I decided to get back into research, and I joined Intel's new microprocessor research lab. And they asked me to write papers to help put the lab on the academic map. And also, the general chart of the lab was, at that time, computers were running spreadsheets and Microsoft Word. I looked at Stanford and I thought, you know, they're plenty good at writing papers, so what else can we do? And I was looking at the state of the field in the late 90s, and it was a mess. Not much work. Everybody built their own code, so if you saw a paper, you never knew whether it was built on bugs. Even if you got their code, it was almost impossible to run. It was spaghetti. And I did see a few labs around the country, like MIT Media Lab, where they had a common infrastructure for students to build on. And so their papers were more interesting and a little more comprehensible. And so when I first joined Intel, one of my jobs to finish off was they were developing these performance libraries, which were optimized libraries, matrix, and some graphics libraries. And I was supposed to finish off part of a image processing library. And through that, I met this Russian team and the key players in OpenCV, Vadim Pizarevsky right away, Viktor Ruhomov. I later met Anna and a lot of people on the team. And so I thought, why not leverage this programming talent for a open source computer vision library, which became the name. At first we called it CV-Lib, but then it became what it is, the open source computer vision library.
I was 24 years old, working for an industrial startup in Russia, city called Nizhny Novgorod. We have been working with various companies from all over the world on various projects, mostly related to video, audio, and image processing. I worked in media codecs project where we implemented MPEG video and audio codecs, and it was a great time. The economy was not that good, but I had a decent job that I really liked. I remember I was invited to the meeting with Intel Santa Clara people who brought the new project. The task was to create computer vision library, but by that time Intel already had a whole set of so-called performance libraries, which included MKL, linear algebra library, Intel version of LAPACK, SPL signal processing library, IPL image processing library, and a bunch of others. So the new library that, as you may guess, should have been called CVL, Computer Vision Library, was to be created and added to this suite. And so we started to argue about architecture, directions, and so on, and so management to decided to move some of veterans to new projects to make atmosphere in that project more relaxed, and at the same time feed some new project with experienced workforce.
We were working with a team in Santa Clara, California, and the project leader was Gary Bratsky, who was traveling to our office regularly. Gary is one of the most amazing people I met in my life. Smart, witty, very kind.
Gary appeared to be a remarkable person. I still consider him one of the best managers. If you ever heard of managers who practice micromanagement or check the time when you start a job, make sure you write all the reports on time, etc. Gary is completely opposite. I'm not saying that he will let you to do anything you want, but at least you feel that you have enough freedom for experiments and your skills are valued and your opinion is valued.
The first function I worked on was distance transform. My math training was pretty good, but almost none of that was in discrete math, so I had to quickly learn a lot of material. And still, I think Vadim was shocked when he first saw my implementation, and with a lot of tact he hinted that I have to rewrite the whole thing from scratch. And after working on that and several more functions like half transform, I started working on the visualization module, and this entertained me for quite some time.
In the build-up to the first official release of OpenCV, we had decided to target CVPR, the Conference on Computer Vision and Pattern Recognition, in 1999 as a big release date. And so we were building up to that, and the key things in the library were some geometric things like calibration that Jean-Yves Bouguet had worked out and helped us, specify. There were basic edge detectors and segmentation. The Russian team brought in morphological operators and various image processing routines. And so all these things were set to go in a workshop that we had signed up for at CVPR in 1999.
2000 was a year of big changes for us. Intel acquired an STL and we became Intel employees. And at some point late 99 or early 2000, I don't remember exactly, it was decided that Intel will release the library open source, and this was big news for us. For the library launch, Vadim and I traveled to the US for the first time. We didn't have credit cards, and so the company gave us cash to travel. Imagine the amusement of a guy in the Bay Area hotel at the reception who realized he had to count a couple $1,000 in cash. We met the awesome team in Santa Clara, many of whom are still my friends, working at Amazon, NASA, Facebook, all over.
I wanted to keep it simple. Many other libraries, such as Microsoft had I forget what it's called, an image. They had a research library. We were competing with them. There was a military one, image understanding environment. There was one at NASA. But a lot of these were complex frameworks, and I wanted simplicity. Like when you wanted an edge detector, you called edge detector. And that turned out to be a winner for most people. And so, it really went on a hit. And it went well, and I ended up, I think, with the team receiving an Intel Division Award for this, and so all that went quite well.
I think I was nervous. It was new country for me, a new conference, big conference, but I understood that library is already on CDs. We can not change anything, at least in this release. So I just tried to relax and enjoy the conference.
The library was announced at CVPR 2000. During the first few months, it was obvious that it was a success, judging by the number of downloads. Many people used it just for the standard functions, like getting a video stream from a web camera, reading an image, and so on. There's so many people from different countries who played a crucial role in the early stages of the library. I possibly could not mention all of them.
And of course people liked it. Many of them maybe wondered how long will that project last, and I think nobody at that moment, including ourselves, could imagine that OpenCV will continue to evolve 20 years later. On the feedback, I remember one funny moment. It was not on CVPR 2000, but at CVPR 2001, 1 year later. We have been showing some new demos, including an optical flow demo, that point tracker demo that tracked points that you set on some person, for example. And the algorithm we used was developed by Takeo Kanari initially, and then improved by Jean-Yves Bouguet from Gareth's team. And one serious man with glasses approached the demo booth, so he watched how points on his body, like tracked, moved after him, and suddenly he jumped to the side, maybe to check what that point tracker is capable to handle rapid motion. And from what I seen, he was satisfied. So I would say it was one of the first like visual feedback when you see that even serious people can enjoy, like children, computer vision algorithms.
In 2005, Intel was changing focus away from OpenCV, as I said, and I had been talking with a professor, Sebastian Thrun, about visiting, so I knew he was coming to Stanford, and I extended an invitation for him to spend time at Intel. So during that time, I guess this was starting 2004, I think, he came and we started working on robotics. It was really the start of my real interest in robotics. And I was coming up on a sabbatical, and Sebastian invited me to Stanford, and he showed me the secret project, which was Stanley. It's going to compete in the DARPA Grand Challenge, 2005 DARPA Grand Challenge. The challenge had run the year before without a Stanford entry, but CMU got the furthest, only 7 miles of like a 130-mile course. So this was the real start of like autonomous driving across the desert. Of course, autonomous driving had been done to an extent, but this was a real competition with the $2 million prize for winning. And so I just decided I'm all in. And again, Intel was telling me, well, you got to move on. And then I started working on Stanley, and I got a lot of people interested, and then I got managers were yelling at me for pulling people off their teams, not doing. And my boss came in and said, this was Bob Liang, he said, you get fired for doing this. But at that time, I meant that I was all in. So I said, it's fine if I get fired. I'm now all in. And so I just kept meeting. And we eventually built up, along with some people at Stanford, the computer vision team of Stanley. And you can read about this. That Stanford team won the DARPA Grand Challenge, completing the whole 130-mile course. It won. It was a historic moment, coming over down the mountain path and into the finish line. I knew at the time that history had changed, that this was the start of something completely new. And Stanley is now sitting in the Smithsonian Air and Space Museum. You can go there, go up to the second floor to the left in the navigation room, and you'll see the car there and it's some of its story. So this was a historic moment, and it really kick-started the autonomous driving industry. Unfortunately, I'm always moving on to the next thing, and I could have stayed with that team who got bought into Google, and they all became quite wealthy from it. I went on. After 2005, they were continually pulling me off OpenCV, and I decided I had enough, and I've done Stanley, and that's when I decided to quit Intel and go on and get on with startups, which is something I had wanted to do anyhow.